Hello class, this is Mrs. Zappia with Eureka Math Lesson 5, Identifying Proportional and Non-Proportional Relationships and Graphs. Our essential question for this lesson is, how can I tell if two quantities are proportional to each other by graphing on a coordinate plane? For our opening exercise, Isaiah sold candy bars to help raise money for his scouting troop. The table shows the amount of candy he sold compared to the amount of money he received. Is the amount of candy bars sold proportional to the money Isaiah received, and how do you know? So our question is asking if the money received is proportional to the candy bars sold. What that means is, does each candy bar cost the same amount regardless of how many you buy? Or do you get a discount if you buy more candy bars? So let's figure out what the unit rate is by looking at the table. Remember, to find the unit rate, you're going to divide the money divided by the number of candy bars. So our unit rate is y divided by x, where y is equal to the money and x is equal to the candy bars. So our first division problem is $3 divided by 2 candy bars. And go ahead and enter that on your calculator or figure it out. And the answer is $1.50. So what that means is each candy bar cost $1.50. Now figure out the cost of the candy bars based on the money received for the rest of the table. So you want to make sure that you're doing this on your calculator instead of just copying it down. You actually want to practice it. So $5 divided by 4 candy bars, and on your calculator that will give you 1.25. So we have, let's see, get that to stay still there. So we've got $5 divided by 4 candy bars, and those candy bars cost $1.25 each. So if you're buying 2 candy bars, they're $1.50 each. But if you're buying 4 candy bars, they're only $1.25 each. So you can already see that this is not a proportional relationship. Go ahead and divide out the rest of them just to prove that this is a correct assumption. So we have $9 divided by 8 candy bars, and 9 divided by 8 is 1.125, and that is $1.13 because of rounding. And then $12 divided by 12 candy bars is just $1 each. So the question was asking, is the amount of candy bars sold proportional? And the answer is no, because there is no constant multiple. A constant multiple would mean that it's the same cost per candy bar. And since you got a different number for each division problem, this is not a proportional relationship. In example 1, from a table to a graph, we're going to use the ratio provided, and this time we are going to create a table that shows the money received is proportional to the number of candy bars sold. So in other words, every candy bar costs the same amount, no matter how many you buy. So we're going to use the original information of a candy bar costing $1.50 each, and we know that because $3 divided by 2 candy bars equals 1.5, which is $1.50. So then let's say that you buy 4 candy bars, and they're $1.50 each. Well, 4 candy bars times $1.50 each. Go ahead and figure that out. And that will cost you $6. What if you buy 5 candy bars? Times $1.50 each. And what if you buy 10 candy bars? So go ahead and pause the video and fill in the rest of this table. So for 5 candy bars, you should have $7.50. And for 10 candy bars, you should have $15. Next, it says plot the points in the table on the grid. So remember, the purpose for this lesson is to be able to look at a graph and determine if it is a proportional relationship or not. So we're going to graph these points. Next, it says, how do we plot the points? Well, first of all, which points? So we want to take our first ordered pair, which is 2 candy bars costing $3. Remember, the first is the x value and the second term is the y value. So when you write an ordered pair, the x is always the first term and y is always the second term. And then on your graph, the horizontal graph is the x-axis, and the vertical graph, or the vertical line, which goes up and down, is your y-axis. So the x is the number of candy bars sold, so we can go ahead and label that. And then the y is the money collected. So we want to plot the first point, 2, 3, and that means 2 candy bars is $3. So we go over to the 2 and then up to the 3, and that is the point 2, 3. The next question says, what is the origin? Recall that the origin is the point of 0, 0. So the origin is the spot right there. Go ahead and plot all of the ordered pairs. So you want to plot 4 candy bars is $6. And 5 candy bars is $7.50. Now $7.50 is not on the graph, but that would be halfway between $7 and $8. And 10 candy bars and up to $15. Now $15 is not on the graph either, but you can imagine where it would be, right about there. So we've graphed the points, and the question is asking, is it proportional? Well, we know it's proportional because every candy bar costs $1.50 no matter how much you buy. But the purpose of this question is to show you if the data is proportional, what would the graph look like? So now I want you to take a straight edge and I want you to draw a line through the points that we have graphed. So we have graphed these points. That's not exactly what I was looking for. Let's do that again. I wanted a line for that, so here we go. So I'm going to take my point and I'm going to put it through here, and I want you to notice that, what kind of a line is it? It's a straight line, and I've got an arrow on the end of it, and that just shows that as I increase the number of candy, my money collected will also increase. The next question, what does 0, 0 mean in this problem? Well, 0, 0 being the origin, the first 0 right here, that's the x value, and that means 0 candy bars. And then the second 0, which is right here, that is the y value, and that means $0 received. So again, the first one means 0 candy, and the second 0 means no money collected. Then I want you to notice that if we took this line that we graphed and we extended it to the origin, now let's get this line. All right, and I'm going to extend it, and notice as I extend it that it goes to the origin. So what we know about a graph that is proportional is that, number one, it is a straight line, and number two, it goes to the origin. So I want you to keep in mind those two things as we write the summary tomorrow in class. The last question on this page, what does one candy bar cost? Well, you can look at the graph for that, and let's see where the X and the Y intersect. So we have one candy bar right here. So if you follow that up to the money, there's the $1.50 right here that one candy bar costs. And remember, that would be the unit rate. One candy bar cost $1.50. For the next problem, this is example 2, and it says, look back at the table from the opening exercise. Does the table represent a proportional relationship, and how can we tell? So this is the same table right here that was on the first page, and we want to know if the table represents a proportional relationship, and how can we tell? Well, we already know that we did the division for these, and we got a different answer or a different unit rate for each pair. So we already know that the table does not represent a proportional relationship. So now what we want to do is we want to graph that data and see if it's not proportional, what might it look like? Then we can answer the question, does the graph represent a proportional relationship? So let's go ahead and answer the first question, does the table represent a proportional relationship? We know that answer is no, because there is no constant unit rate. Then how does the graph represent a proportional relationship? So let's graph that data. So we've got 2 candy bars is $3. And graph this on your paper while I do it on the screen. 4 candy bars is $5. 8 candy bars is $9. And 12 candy bars is $12. So let's go ahead and attempt to draw a line through that and see what that might look like. So notice what happens here. If I've got it through those 3 points, then the top dot's not on the line. But if I go through these points, then the middle dot is not on the line. So that's not exactly a straight line. So I'm going to go ahead and instead graph each one individually. So let's get this back here where it belongs, and then let's do another line to show you what that looks like. So take your straight edge and connect each line to its next point. And you can see that although it's close to straight, it's not exactly straight. So does this graph represent a proportional relationship? Well, remember on the previous example, the proportional relationship shows on the graph that it is a straight line and it goes to the origin. Both of those things have to be true in order for it to be a proportional relationship. So does this graph represent a proportional relationship? And the answer is, let's change that to a pen. The answer is no. How do you know? Because it is not a straight line. Now you might be thinking that, but we haven't put it to the origin. Well, if it's not a straight line, it's not proportional. In order to be proportional, it has to be a straight line and go through the origin. Since this is a straight line, it doesn't, since this is not a straight line, it doesn't matter that it doesn't go through the origin because it has to be straight to be proportional. In example 3, graph the points provided in the table below. And then, how are the graphs of the data points in example 1 and 2 similar, and how are they different? So first, let's just talk about this one. How are the graphs of the data points of example 1 and 2 similar, and how are they different? So the data points in example 1 and 2, let's make sure we're in the right section here. All right, so the data points in example 1 and 2, one of them had a straight line and the other one didn't, and they both go to the origin. So let's take a look at this example, and you think, well, we didn't draw the point to the origin. But if you graphed if you buy 0 candy bars, you would get $0, and then we draw a line there. So it does go to the origin. So the similarities is that both of the graphs have 0, 0 plotted. But the first graph was a straight line, and the second graph is not a straight line. So that's how they are similar and different. We're not going to write down that answer, just talk about it. So what I do want to answer in this problem is, does this graph represent a proportional relationship, and how do you know? So let's take this data here and let's graph the points. We don't know if this is about candy bars or money or what it's about. So then you think, well, how do I graph it? Remember that the first column is the x value, and that is going to go on this axis right here. And then the second value is the y value, and that's going to go on the y-axis, which is labeled right there. So go ahead and pause the video and record your data. Over to 3, up to 9. Now, 9 is not on your graph, but 9 is between 8 and 10. So we'll go over to 3 and up to 9. Over to 6 and up to 12. Over to 9 and up to 15. 15 is not on the graph, but it is between 14 and 16. And over to 12 and up to 18. Now the question is, does this graph show a proportional relationship, and how do you know? Well, two things have to be true. It has to be a straight line, and it has to go through the origin. So let's check to see if it's a straight line. Take your straight edge and connect your points. All right, so let's see. That doesn't exactly look like a straight line. I'm going to do that one more time. So I'm going to take a line, and I'm just going to double check that. All right, so yes, that is a straight line. So is it a proportional relationship? Well, does it go through the origin? This is not a proportional relationship. I'm just going to write with the dotted line. This is not proportional. And then the question is, how do you know? I kind of like that pen. How do you know? The line does not, can you read that okay? Go through the origin. And you'll want to keep that in mind as you're doing your summary in class tomorrow. This is not proportional. Why? Because the line does not go through the origin. All right, let's see where we are here. So we're at the summary, and we're going to answer the summary as bell work tomorrow. And remember, when we do the summary, you're going to be answering the essential question, which was, how can I tell if two quantities are proportional to each other by graphing on a coordinate plane? So we'll answer that question tomorrow. Remember that this was a proportional graph here, because it's a straight line and it goes through 0, 0. And then in another example that we did, this one is not proportional because it is not a straight line, even though it goes to the origin. And this example is not proportional because although it is a straight line, it does not go through the origin. So in order to be proportional, it has to do two things. It has to go through the origin, as it does in this example, and it has to be a straight line. Then you know the relationship is proportional. And again, proportional means that you're paying the same amount per candy bar, no matter how many candy bars you're buying. You don't get a discount if you buy more. That concludes our lesson. That's a wrap. See you tomorrow.